Radiation. In space, no one can hear you scream. It's kind of like having to be silent in the middle of a horrible GCSE exam. But while sound can't travel across the vast emptiness of space, remember, sound needs particles, or a medium as it's known, to travel, the light and heat from the sun can, as I found out to my peril last summer. Absolutely brutal sunburn. The method by which this energy travels across space is the final method of heat energy transfer: radiation. Now, it's important, straight off the bat, not to get this type of radiation confused with the nuclear bomb, glowing green goo stuff radiation. Radiation just means energy moving away from a source. And this is why this term applies both to the ionising radiation of nuclear sources and to the transfer of heat in this manner. The heat energy is transferred by infrared radiation, and this is an electromagnetic wave, which means it's a simultaneous disturbance in an electric and a magnetic field. These waves are absolutely everywhere. Visible light is an electromagnetic wave, it's exactly the same thing. The microwaves that transmit the data across the Wi-Fi you're using or the mobile network to your phone or computer so you can actually hear this is another electromagnetic wave. Infrared is the electromagnetic wave responsible for the transfer of heat. Every object emits infrared radiation, and the amount of radiation emitted depends on the temperature and the properties of that material. We can't usually see these infrared waves moving away from objects because our eyes can't see them, they're tuned to the visible light. But if we use an infrared camera, we can. It's important to remember that everything emits this radiation, just in, sometimes vastly, different amounts. One factor that affects the amount of this infrared radiation transferring the heat energy to another location is the colour and type of the surface. If you picture the people who live in desert places like Saudi Arabia, they often wear light white long robes and also white cotton head garments. The colour white is great here because it reflects the infrared radiation beating down from the sun, meaning that the person stays cooler. If, on the other hand, the job is to absorb as much heat as possible, like, say, the thermal solar panel that you might see where they make hot water for you, you would use the colour black. Black is superb at absorbing infrared radiation. And that being said, black is also the best at emitting this radiation back out, and white is the worst. Also, if the material is shiny, it will reflect more of that infrared radiation and keep the object cooler, and a dull matte colour will absorb it better. Just think about light here. If you had a shiny surface, it's going to reflect more light. If you have a dull surface, you don't tend to get any reflected light. Remember, infrared is just a form of light, but this is the light which transfers heat. The key is also to remember that if you want to make something hot, matte black. If you want to keep something cool, shiny white. One way I remember this could be that if you remember the colour of an object you see is just the colours being reflected. And this could be confusing, but a green leaf absorbs all colours except green. It's kind of the colour it actually hates the most. White objects, therefore, reflect all colours, as white is what you get when you have all the colours there. Black absorbs all the colours. That's why you see the colour black. So if we remember that infrared is exactly the same as light, but transfers heat, white is going to reflect way more light, and black is going to absorb more. Finally, the examiners occasionally like to ask about different heating implements and how they can be more efficient so as to not waste heat energy. An example of this would be putting tin foil behind a radiator, so any infrared emitted towards the wall and possibly out of the house is reflected back into the house, making the radiator more efficient, and actually live up to its name by radiating rather than convecting. Another example is how a vacuum or thermos flask keeps things warm or cool. They consist of two bottles inside one another with a vacuum, space with no air, between them. This means that conduction and convection will essentially be zero, because remember, they need particles to work. And the hot tea or cool drink can only lose heat through radiation. In effect, a vacuum flask is using the power of the vast emptiness of space in a bottle to keep your tea warm. Lovely. In short then, radiation is the transfer of heat energy using infrared electromagnetic waves, which can travel across all space. Black, dull objects are great at absorbing and emitting it, and white, shiny objects reflect it back. Questions. Name all 7 electromagnetic waves on the electromagnetic spectrum. Do you know use for each one? Why is the radiator on a car engine usually painted black? Some gases can trap the infrared radiation of the sun in the Earth's atmosphere. Name 2 of those gases and the effect.